The final chapter for the term covers glaciers and glaciation. So glacials have a special important glaciers have a special importance in the natural environment, and also as we look at climate change. And I think some of the flooding research that you did really focused on, what happens if we lose glaciers worldwide, what happens to our water supply, what happens to coastal landscapes. So they're very important in just the life as we know it. So we're going to look at just again the movement. We're going to look at depositional and erosional landforms, and we can classify glaciers into two major kinds: continental glaciers, which are very large, South Pole, Greenland, and alpine glaciers. And a glacier is considered, I'm going to shrink this down. I think I've got, a glacier is considered, I think in the text, to be a river of ice. It moves, it flows, it's very brittle, but it's also ductile or plastic at the same time. And a glacier has different regions within it, so that the base of the glacier may move differently than the middle of a glacier or the top of a glacier. And this is important in transport of material. So alpine glaciers are very discrete landforms, and this is just a lovely picture. And what I really like about this is we get this sense of glaciers being kind of white and nice and snowy, and really they are covered and filled with rock and gravel and sand and sediment. And this glacier is just a great example of all of the rock that's fallen off the cliffs kind of being embedded in the glacier. And this is more of a continental glacier, very large scale glaciers. First, the idea that glacial snow is different than regular snow. Glaciers start out, of course, as snowfall, and it make sure you understand in the part of the text that talks about how glaciers are formed, and basically reminds me a little of a metamorphic rock, in that you have snow and ice that becomes more compact as more snow and ice lands on top, and it really creates this very different snow that goes from snowflakes to granular snow to a product called firn, and then it melds into glacial ice. Continental glaciers move then under their own weight, so the pressure and the weight of a mile of snow and ice that push and radiate and move out in all directions. Alpine glaciers tend to flow under the weight of gravity downslope. So when we're looking at a continental glacier, these are huge structures. So the diagram here is, say, hundreds of miles, and there's many components of glacial material. So the bottom of the glacier tends often to freeze to the base of the rock, and in doing so it'll freeze around gravel and rock, and as it slides or moves forward, it will pluck up that gravel and incorporate rock and gravel within the glacier itself. The top of the glacier then, as it moves, is very brittle, and it can crack open, and these are what are called crevices. The middle of the glacier tends to be a little more plastic, and so the middle zone of the glacier actually moves faster than the bottom or the top of the glacier. So make sure you go through those aspects in the textbook of how material is moved in a glacier. Sediments then, the material that's picked up in a glacier that's deposited by ice, is called till. Till is very unsorted, so it could be large boulders to very fine clays. And here's an example of glacial till. A stream is going to have rock layers that are very similar in size, because those are dependent on the competency of the stream. So if the stream is running slowly, it picks up small particle sizes. If it's running with a lot of velocity, it'll pick up large sizes. But a glacier is much more like a bulldozer, and the material left behind by a glacier really demonstrates that. So you have large rocks embedded with very fine silts and clays. The bottom or the base of a glacier often has a lot of water running underneath that glacier, and material will run out through the toe or the end moraine of the glacier, and that material is called outwash, and this is a great example of glacial outwash in Alaska. Sometimes glaciers can have very fine materials, and these are called glacial clays, so make sure you understand how all of those materials get defined. When glaciers deposit material or are off the landscape, there are many kind of evidences that glaciers have been here, and here's an example of a glacial erratic. This was a large boulder that was embedded in glacial ice. As the ice melted and retreated, that boulder was left behind. Another example of glacial material would be ridges called eskers. And so an esker might be a water evacuation tunnel underneath the glacier. So maybe this is like a stream running under the ice, but the stream fills with sediment. And on the landscape, eskers make long ribbon-shaped mounds. Another landform left from continental glaciers are called kettle lakes, and as pieces of ice break off the end of the glacier as the glacier is retreating, that ice can be covered and embedded in glacial outwash. Then once the ice melts, it leaves a divot and then eventually fills with water. And here is a landscape, I think this is in Wisconsin, that shows all of these holes or these small lakes. You might think this is karst landscape, but actually you can look at the shape and the size of these and also the material they're in. It's not limestone, it's till. Glaciers also leave distinctive erosional landscapes of grooves and striations and larger mountain-size erosional landscapes. So these are, they look like slides, but these are glacial grooves, glacial striations from rock that is embedded and frozen into the bottom of a glacier that scrapes over the landforms. This is called chatter marks and polish. So if I had rock and sand in the bottom of a glacier, it could also work to smooth a rock, but it can also freeze to pieces of the rock and pluck off pieces and take it as it moves. And then the last landform for glaciers is roche mountainais, and these are used to kind of predict or to reconstruct the movement of glaciers. So in these landforms, the backside, they remind me a little bit of sand dunes, but the backside of this is smooth and abraded, and the front side, or in the direction of the movement, is plucked. And here's a landform that shows this great hill that was shaped by glacial movement. Alpine glaciers, then, when we're looking at erosional remnants or erosional landforms, we're looking at arêtes, which are like knife-like ridges between two glaciers. Horns, you know the Matterhorn, I don't mean the one in Disneyland, but their horns are areas where 3 or more glaciers have eroded back, leaving this large remnant tower. And glacial valleys. And glacial valleys are very distinctive in their smooth kind of U-shaped form rather than a regular river valley, which is much more V-shaped form. So again, alpine glaciers move in the same way as continental glaciers, where there's a brittle zone at the top. The crevasses only go as deep as the brittle zone. That's usually about a couple hundred feet. And then the middle of the glacier is much more plastic, and it moves much faster, creating kind of this churning motion as the glacier moves downhill. So alpine erosion will leave those features I mentioned earlier, cirques, which are small erosional dishes or curved areas that fill with water called lakes, paternoster lakes, which are a series of these cirques, horns, arêtes, and the glacial trough. So let's look at a couple of those. This is a nice example of a glacial trough. It's very U-shaped. You get that sense of erosion, not just along the bottom as a stream would do, but along all the edges as the ice was frozen in that area and moved outward. This is an example of an arête. You can see there's erosion down both sides and this nice valley back in there. Here's a series of paternoster lakes that as the glacier eroded and moved backwards and dug these small erosional divots in the landscape. A glacial trough, just a nice example of a U-shaped valley, and often glacial troughs such as this one are now being eroded by regular fluvial erosion. And a fluvial valley or a river valley is much more V-shaped. Glacial troughs are U-shaped. Another example of an arête, and this would be a horn. So alpine deposition, what we're talking about is the till that you saw and outwash that you saw in continental glaciers. But these landforms tend to be on either side of the remnant glacial ice, so they're called moraines. And lateral moraines mean material along the side. Medial would be material in the middle, and terminal moraines would be at the end. So this one actually shows really nice lateral moraines. You see these ridges on either side of this active glacier. A terminal moraine or an end moraine is at the bottom, and this glacier is melting backwards. It's ablating, and the material then is filling up down toward the bottom. In Oregon, we have a really nice example of lateral and end moraines at Wallowa Lake, and here is kind of a postcard example, but this is actually the moraine or the lateral moraine that was the depositional material on the edge of the glacier. And as we talked about in the beginning, that we're really looking at glacial change and retreat, and so this is a little bit granulated, but on the left in 1859 there's a photograph of the Rhone Glacier, and you can see it coming down, into this small town. These houses built at the base of the glacier, and right now the glacier has retreated to about here, which would be about that place on this photo. And I think there's one more picture. There's the historic photo of the glacier, and now it's up here. So that truly is a concern. So again, use this as some way to kind of supplement your reading. Go through the questions. Make sure you can answer all those questions and you have those answers ready when you take the exam.